Hi everyone, welcome to AI Product Builders. Today we'll be building a GenAI application using LLMs and RAG framework. This app is an advanced question answering platform that allows users to upload multiple documents and receive answers to their queries based on the context of those documents. We'll be using LangChain and openai LLMs to build this application. So by the end of this video, you'll have a fully functioning end-to-end AI application built using openai LLM and deployed on Streamlit, so you can share it with others. So let's dive in and start building. So let's quickly understand how the application works. The application is called Ask the Document app. This app is an advanced Q&A platform that allows users to upload any text document and receive answers to their queries based on the context provided in the documents. So here we'll be utilizing RAG approach powered by OpenAI GPT models, and the app provides you very insightful and contextually relevant answers. So how it works is you upload a document, you ask a question which are relevant to the documents and get answers instantly. So I'll start by uploading 2 files over here. I've uploaded personal documents of mine. Srilakshmi personal info contains a lot of information about me, my strengths, weaknesses, where do I live, what's my favorite food. Srilakshmi resume contains information about where I work and what do I do. And also you have to enter your question. So I'll just say where is Srilakshmi from, and enter your openai key. Later in the video, I'll also show you how you can get your own API key and click on submit. Srilakshmi is from Bangalore, India. I'll start another question. Srilakshmi friends. Take your openai key again. Click on submit. Srilakshmi strengths are resourceful, collaborative, proactive. This is exactly what I provided in the document. Let's have a quick look into how can we build this. So let's quickly try to understand how the application works on a high level and also the tech stack. So we'll be using mainly LangChain over here. LangChain is a framework that helps developers create applications using LLMs. It's an open source framework that provides tools and abstractions to improve the accuracy, customization, and relevancy of the information generated by these AI models. And we'll be using Streamlit. Streamlit is an open source Python library which enables developers to create web interfaces within no time. So we'll be using OpenAI as an LLM model over here. So once the user uploads the document and the question, character text splitter is a function which splits the document into chunks. So let's understand why chunking is important, right? Chunking is the process of breaking down these large documents or pieces of text into smaller segments. It's an essential technique while building an LLM application to help optimize the relevance of the content we get back from an LLM. And then we pass those chunks into OpenAI embeddings. OpenAI embeddings basically encodes the document chunks or strings text as embeddings. So let's also understand why do we need to create these embeddings. Machines usually don't understand words in a way humans do. They require a transformation of a text and image into format they can process. They understand numbers. So an embedding is a way of representing complex information like text or image with a unique set of numbers. So what OpenAI embeddings do for us is encode the document chunks or a string of text as embeddings. So the distance among these embeddings provide a measure of relatedness that determine the similarity or difference. So, and those embeddings are stored in a vector database. So Chroma is a vector database here, is an open source embedding database. And after storing the documents on a vector database, we pass it to Retrieval QA. It's a question and answering chain that takes as an input argument the LLM via the LLM parameter, and then we generate an LLM generated answer. So that's how the application works on a high level. Let me also quickly show you how you can get your API key. So head over to openai.com and click on Explore API. Just log in with your account. If you don't have an account, just create one and click on API. So you end up in OpenAI developer platform. And once you end up here, click on API keys and click on create new secret key. Just give it a name and say create a secret key. I already have my secret key over here and save it in a very safe place. That's how you can get your API key, and you can also see your storage, the usage of your API key. Yeah, that's basically it. So this is my GitHub repository. Basically consists of your three files: readme, requirements.txt, and streamlit.py. README consists of the basic details of the application. Requirements.txt consists of all the libraries you need to import for this application to work. And streamlit.py consists of the code base. So start by importing all the libraries, as I've mentioned. So in order to import all the libraries, you have to mention all your libraries in requirements.txt. Just say pip install requirements.txt. It says requirements already satisfied. So once you import all the libraries, we'll start writing the code. So we'll start by generating a custom function called generate response. It basically takes three arguments: uploaded files, API key, and query text as an input. And we start with the documents and empty string. This function basically contains the bulk of an LLM pipeline. And then this function has 4 steps. First, it splits the document into chunks and select the embeddings, and store those embeddings in a vector database, and then create this retriever interface, right? So first we'll be using a utility function called character text splitter from LangChain. It basically splits the text into smaller chunks on character count, which can be useful for processing large documents or for chunking text for input into large language models. And then we are using a class for generating embeddings using openai's model. Embeddings are vector representation of text that capture semantic meaning. And then we are using a class for creating and managing vector store. Here we are using Chroma. Vector stores are used to store and retrieve embeddings efficiently. And then we are using Retrieval QA. This class designed to handle retriever-based question and type answering. This involves retrieving relevant documents or chunks of text before an answering. So in a nutshell, what this function does is basically takes an upload file, an OpenAI key, and query text as a text, processes the files to generate response based on the query, and returns the answer. First, it starts by reading and decoding each uploaded file and splits the text into smaller chunks, generating embeddings for those chunks, storing those embeddings into a vector store, and then using retrieval-based QA mechanism to generate an answer to the input query. That's basically what this function does. Once we are done with the function generate response, we write code for a Streamlit web interface. To set up a page title in Streamlit, we use st.setPageConfig, and for in-app title, we use st.title. And to describe basically about the app, we use st.write in Streamlit, and for heading, we use st.header. We include instructions on how the application works, basically telling a user that upload a document, ask a question, and get instant answers. And then we have to create 2 input fields. As you see here, we have 2 input fields. One where user uploads the document, and one where they enter their API key. So using st.fileUpload of Streamlit, we ask user to upload their documents, and using st.textInput, we ask the user to enter their question. And this part of code is part of Streamlit application. It handles the form submission, including collecting the API key, checking the form has been submitted, and generating a response based on the uploaded files. First, we'll start by initializing the empty string. This list is intended to hold the responses generated by the application. With st.form, this line starts as a context manager that creates a form in the Streamlit app with the identifier st.form, and then this is where the user enters their OpenAPI key. So we provide a text input, and then we create a submit button for the form with the label submit. Similar to the API key input, the button is disabled unless the user has uploaded their files and entered their query. ensuring that form can only be submitted when it's meaningful to do so. And this part of the code is the validation check. Check if the form has been submitted and if the provided API key starts with SK. So usually the API key from OpenAI starts with SK, which is a common prefix for such keys, indicating a secret key. This serves as a basic validation step for the API key. And with st.spinner, we display a loading spinner saying calculating on the Streamlit app while the code block inside the context manager is running. This provides visual feedback to the user that the request is being processed. And this is where the magic happens, right? With the generate response function, which we defined above, is expected to process the documents and query to generate a response based on the content of the uploaded files, and then appends the response obtained from the generate response function to the result list. This allows for storing the generated response for later user query. And then finally, we delete the openAPI key for security purpose. We don't want to save anyone's openAPI keys, and that's what we do. And then we display the response. And finally, we are also including some instructions on how users can get their openAPI key. For example, if you look at the app, here I mentioned some instructions on how user can get their openAPI key. So in Streamlit, if you want to include some kind of instructions, as I mentioned, you should be using st.write, and that's what I've been doing here. Now that you're done writing the code, let's run the application. Streamlit API, and then you open in a browser. You see whether your application is working, upload your documents, enter your API key, and ask a question and see if the app is working. I already checked and it's working perfectly for me. So once you know the application is working, you can also deploy this application on Streamlit. This is a cool way to share your application with others. So let me quickly show you how you can deploy your app on Streamlit. So to deploy your app on Streamlit, all you have to do is head over to Streamlit. You create an account with Streamlit, head over to Streamlit community, and you see something called new app over here. All you have to do is paste your GitHub URL. So here's my GitHub URL. Once you paste a GitHub URL, you also see a domain. You can also edit this domain and click on deploy. As you see, my application is deployed on Streamlit, and now I can share it with others. So that's it for today. Thank you everyone for watching. If you enjoyed this AI tutorial, please do share and subscribe. More such exciting AI projects are on the way, and I'm very excited to share them with you. Stay tuned and see you.